So now we are going to the next item on the program, which is a sponsor talk, the first one before the lunch break. So this sponsor talk will be provided by Juan Antonio García Carrasco. Hello? Yeah. By Juan Antonio García Carrasco, who is a senior consultant in HPC and quantum computing at Fujitsu. The title of his talk is Future and Current States of Hybrid Supercomputing. So, whenever you're ready.
Okay. Thank you so much for being here. I guess you are hungry, so I try to make my presentation shorter. Well, maybe the screen is not showing the presentation. Here. Please, you give me a pen, I can draw the slides. Well, we can try to turn the monitor. No. Okay, thank you. So, we are trying to, not talking about hybrid supercomputers, but what we mean by hybrid supercomputing and what the steps we are trying to do in that direction. Well, what we mean by hybrid supercomputing, but in short, it could be a tool, not a tool, let's say a solution. I don't like this word because it's a bad word, but anyway. A solution to try to solve the more complex, or the day-to-day more complex problems in real world, in society, and in industry, using the best technology in any case for any problem, using the better tools, the better hardware, underlying hardware, and whatever. So, in fact, the key to obtain that solution or to do that could be to have, as you can see in the slide, in the top, an orchestrator or a layer of mainly software that can elect the proper algorithms and execute these algorithms in the better hardware that can find the better solution for a complex problem or for any part of a complex problem. So as far as I know, this tool is not exist today so far. But there are many approaches to obtain a solution like that. No? In the case of Fujitsu, we develop some tools, some software component called workload broker that allows to select for a complex problem what is the better algorithm that can resolve or can solve this problem better and execute these algorithms in the better underlying hardware. That could be classical hardware, HPC plus AI, or quantum hardware with an emulator or quantum computer. This is the basis of computing as a service platform that we launch in Japan, and probably next year we can have this platform also in Europe. And another tool or another solution to do something like this is our Kozuchi AI platform, but it's something different. The Kozuchi platform, this AI platform, allow us to to make complex AI models, in particular machine learning models or deep learning models, using different tools available in the market, OSS or proprietary, and build quickly proof of concepts. So using AI and machine learning particularly. We will talk about later about this platform. As you see in the picture, the underlying hardware that we are trying to talk about is the hardware that you can do you know HPC platforms, HPC prepared for traditional AI workloads, but also for traditional and AI workloads. In this case, every manufacturer has the same tools, the same components. The servers are a commodity, you know. So in our case, we have a differential value with our FX700 and 1000 platform based on our ARM processor, as you probably know. And this platform can be used not just for traditional HPC workloads, but it can run efficiently also AI workloads, and without the need of a GPU. If you have a GPU and you are using completely the machine learning training, pues in this case you have the GPU use it all the time, but in many cases your accelerators or GPUs are underused. So in our case, there's no need for GPU because all the compute is in the CPU. Another kind of solution that are emerging today is quantum-inspired technology. In this case, there are several approaches. We will see more details later. We have two products, and also we go in deep in some of our products in this category. But in general, the quantum-inspired solutions are based by using emulators or simulator in software, and also easy machines or adiabatic computing or other technologies is not purely quantum, but inspired in quantum mechanics for their operation. And finally, as you know, we have the quantum computers with little practically today, but this technology is evolving very quickly, and probably we have a lot of better results, or we can use this technology for solve not real world problems, but some parts of complex problems in a more efficient and quick way. So before to talk about more specifically about quantum solutions, we will show some picture of what is the state of the quantum race today. And as you see in the slide, there are one part, the left side is used by hardware, classical hardware and classical software, to use, as I mentioned before, quantum mechanical theories to improve some design of algorithms or technical solution. In this case, in Quantum Spire, there is a few manufacturers that is working in easy machines, making software or using classical software or hardware or both. In this case, Fujitsu, as I mentioned, has the digital annealer as a solution for this field. And also Hitachi Toshiba are working in this kind of easy machines. In the part of classical but emulator or simulation of quantum states, we have a lot of manufacturers and a lot of solutions, OSS solution, and also proprietary solution to make quantum emulation or quantum simulation. Emulation and simulation, we mean, when we talk about quantum emulation, we mean piles of software that emulate a quantum computer, a gate-based quantum computer. And when we talk about simulation, we mean many-body simulation or quantum physics simulation. In this case, there are several manufacturers that are working on these kind of platforms, and they have very great products. In the field of quantum annealing, we can identify D-Wave as the leader of this technology. They are providing quantum annealing solution since I don't know, maybe 10 or more than 10 years. And finally, in the right side, the quantum computing, quantum computers based on many technologies, ion traps, superconducting, as you probably know, the more typical, the multiple physical qubit implementation. But also another emerging technologies are running. Later I will talk about some of them. And in this case we have, as you probably know, a quantum computer made with a joint collaboration with RIKEN, 64 qubits quantum processor. Later I will tell you more details about this platform. What is the Fujitsu strategy in quantum technology or quantum computing? Well, our strategy mainly focuses in 3 points. One point is not use only just a solution, a hardware solution, but partnership with leader institutions in other promising technologies, and develop and work with them to develop new technologies in quantum computing. Second, the second point is not focus only in hardware, but also in software and applications. And third, and then the third point, or third key point of our strategy in quantum computing is to use our simulator or quantum simulator or emulator to build with customers in a co-creation fashion model, make use of new algorithms or quantum algorithms to solve real problems and or part of complex problem with these kind of technologies. As you can see in the slide, we are working in several areas. In the quantum application, we are working with Fujifilm and other companies in quantum chemistry, and also in financials and other application areas to develop application or algorithms, quantum algorithms to solve certain problems, or part of the complex problems in that areas. But also we have working with several companies, several alliances and partners. In the case of algorithm design and error suppression, we are working with QNASys, and also con Keysight Technologies with Professor Emerson. He's the head of quantum strategy in Keysight. And in particular in error correction, we have a joint development, joint research agreement with Osaka University, and recently we provide or we reveal a new development with them to reduce the requirements of the physical qubits to produce error correction in quantum computers. With this new development, we can reduce the requirements of these physical qubits by 90%. So we reduce from 1 million to 10,000. To take an idea of what this means, if we can build a quantum supercomputer of 10,000 qubits, noisy qubits, with only 64 logical qubits, we can obtain a performance of this computer 100,000 times the performance of any actual supercomputer, big supercomputer. And in the lower layer, just in the hardware layer, the device professor built and also the control circuits and so on. We are working not just in superconducting technology, but also we are working with Technical University of Delft in Netherlands in a new implementation of qubits using MB centers. Later I try to explain a little bit more in detail what this technology means. But we don't stop here. We are trying to find out other companies, other technologies, and develop new ways to harness the quantum technology to produce better results, solve more complex problems, and so on. Here you can see three other main solutions in quantum technology space. As I mentioned before, the digital annealer is our solution using classical hardware and classical software to solve specific problems of combinatorial optimization problems, and we are working in this technology since 2018, I mean. And we are now in 4th generation of the digital annealer, and we have a solution. Mainly it's a cloud solution, but I try to provide also as on-prem. And this 4th generation can solve complex problems because they have a scale of 100,000 bits to solve optimization problems. And probably this year or maybe next year, we can provide a new generation, the 5th generation of digital annealer with 1 million bits of scale. to solve more complex problems in optimization, combinatorial optimization. As you can see, we have been working with several customers during 5 years, making POCs and testing our technology and demonstrating that this technology could solve these problems better than other solutions based on software or based on other heuristic or methodology for solve optimization problems, you know. And second one, in quantum emulation, we revealed last year our quantum emulator, the fastest quantum emulator, state vector quantum emulator in the market, as we published in an archive document that you can see in the internet. And with this emulator, we can use for any kind of problem up to 40 qubits actually. In this case, one of the key points of our software or solution is a combination of hardware and software. We develop our emulator using our FX700 platform. So we improve this software to use this hardware and the high bandwidth to access memory to obtain the result that we publish in the paper. One of the key things is this software, the MPI QLAX, is based in QLAX. This is a software, theoretically the fastest software running in one node to emulate quantum states or state vectors. And we adapt this solution, but this solution is open source. We provide with no cost the emulator, but the solution, emulator and hardware is you only pay for the hardware and the integration of the solution, but the software is open source. MPI QLAX. Several customers ask me about why I need a quantum emulator if I can buy a real quantum computer. Well, it's a good question because many customers don't know why they need a quantum emulator, and a quantum emulator is necessary in the field of quantum development for several reasons. The most important could be, first of all, you need to learn to code a quantum computer without the expensive resources of a real quantum computer. This is the more simple. But also, we need a quantum emulator to visualize the internal data of your algorithms. In a real quantum computer, could be very difficult or maybe impossible to know the exact values of the data during the execution of the quantum circuit. And also, it's necessary to prove new algorithms at low scale and then launch them in a real quantum computer. Also, it's important to have an emulator to verify expected results. It's not easy to know what are the results of our algorithm, and with an emulator you can prove this and test this. And finally, you can also design and test error correction codes in emulator in a easy way, and then prove them or execute them in a real quantum computer. And I'm talking about quantum computer. As you know, we have a joint development with RIKEN for a 64 qubits superconducting gate-based quantum computer. We plan to have 1,000 qubits in 2026, 100 in next year. But also we have working in another technologies with to Delft University, as I mentioned before. We are working in spin diamond qubits that they have a lot of advantage. Maybe I have no more time to explain in detail because I have no time. No? Let me 1 minute to close or to try and explain briefly what this technology works and what are the advantages. The diamond spin technology of making a qubit is based on the MB nitrogen vacancy centers, or MB centers. An MB center is produced when you extract or you replace a carbon atom by a nitrogen atom, and the neighboring atom of a carbon atom is removed. So you have a vacancy. In this case, you have in the lattice of the diamond, you have a neutron, nitrogen atom, and a vacancy. In this vacancy, un pair electron is trapped and turn around the vacancy, making a spin, electronic spin, that could be used as a qubit. But also this spin copes with the nuclear spins, adjacent nuclear spin. So we have many candidates to several qubits in one module or one diamond module. And the great news is the electron spin has a coherence time of several seconds, maybe 1-2 seconds. So it's better than any other technology as the superconducting basic technology. But also, another great news is that we can measure the state of this spin, of this qubit, using photons, so using photonic links, and we also make the entanglement in between several qubits using photonic bonds. So this allows us to create better and bigger quantum computers using photon links to make the entanglement and also to make the measuring of the state of the qubits. Sorry for that, I consume all the time. Thank you very much. I stop here, sorry.
I'm sorry, there's no really time for questions, but anyway, Juan Antonio, maybe you can stay around for a little bit in case that you want to ask him something in particular. Thank you, Juan Antonio, for everything. Thank you for the interesting talk.